Welcome back. The story continues. Week 10, video 5, other special methods. So we're going to look at a slightly fancier operation we can do with our wonderful new color class. So we've got a color class that you can initialize, you can convert it to a string in one of two different ways, and you can compute the lightness of the color. I'm going to look at how we might possibly do arithmetic on colors. So if you were to take any integer, for example, I is 10, and do a dir of I to find out what methods it has, you would find a few familiar sounding things like dunder add, dunder sub somewhere down here, dunder sub, dunder mul sound like you might be able to figure out what these things do. There's a dunder mod. I'll let you look around in those for a minute. So it probably doesn't come as too big a surprise to you to know that if I talk about x as a value 200, x dunder add 99, you're not surprised to know it gives 299. And in fact, what happens here is that if you type x plus 99 into the Python shell or in your Python program, it gets converted by the Python engine to a call on the dunder add method of the variable x, giving it the parameter 99. So this gives us the ability to write our own arithmetic operators. Now there's a heap of them there, and I'm just going to give you an example of one of them, namely the add. There's also things like there's the dunder LT for less than, multiply. Division's a little bit tricky because there's two sorts of division, but true div here is the single slash operator, and there's also something called floor div, which is the double slash divide operator. So you can implement by overriding or replacing the sort of default essentially useless methods that you get in your class with ones that actually do what you want. So I'm going to do something relatively simple. I'm going to define dunder add on a color. So it's going to take the self object, because this is going to be of the form of the self object is x here, and the value we're going to add to it, which is the other item. So I'm just going to say returns the sum of, sum of self plus other. How do we do it? Well, we're going to construct a new color which has the components made by adding self to other. So red is going to be, in the first instance, we'll try self.red plus other.red. Green is going to be the self.green plus other.green. And blue, big surprise here, is going to be self.blue plus other.blue. And I'm going to return that as a color. Return the color red, green, blue. So with that little trivial addition to my class, let's run it and see what happens. I'm going to have C1 is the color 10, 20, 30, and C2 is the color I don't know, 100, 50, 60, well, okay, 60. I don't care what my fingers type. What's C1 plus C2? Bingo, it's the sum of those, 110, 80, and 80. So with that little addition there, I can implement addition. Haha. Little addition, I can implement addition of colors. If I wanted to do multiplying of colors, of course, I'd have to do dunder mul, division, and so on. So what we're seeing here is the results of adding two colors, sort of. Now there's a bit of a problem with the code I've got, and I'd like to demonstrate that. Let's suppose we've got the color yellow, which is, as I've shown you before, the 25525550, so there's no blue in yellow, it's got red and green mixed to the maximum. And let's take the color white, which is color 255255. Now what do you expect to get if you add yellow to white? Well, what we actually get is some color which is illegal, because remember I said that the maximum values these can have is 255. So if I'm going to stick to the rules, if I take white and add some yellow into it, I should put a limit on the maximum value I can have. So I should change all this code so that it's the minimum of 255 and that color. Now minimum seems slightly odd. What I'm trying to do here, is limit the maximum value it can have. So if the value goes over 255, then we will use the value 255 instead. Okay, so now I've modified the code, and with that modification, when I redo that, and if I define my yellow and my white and now do the sum of them, I now get white. Now, if you've done much work with cameras, you'll possibly get some vague inkling on what's going on here. If you limit colours, the colour range to a certain range, and you oversaturate, that is, you've got too much light coming into your camera, then everything washes out to white. So if I get too much of yellow or too much of anything else, it'll turn into white. So that's what's happened here. I've got pure white already. That's like looking at the sun. It doesn't matter if I try and stick a little bit more in there, it's not going to change the colour. So there's my modification, and I've shown you how we can add colours. If you wanted to do the full-on complement of everything that's available, you would have to look at how to do things like comparison of two colours. Are they equal? Is one colour less than another? How would you compare less than? Would you want to compare it on the lightness? You might do. Or you might say, well, it's undefined, and you might want to create an error if anybody ever tries to do less than. You have to define for yourself what you mean by these operators when you're writing a new class. Really, all at this, or at this stage, all we want from you is that you understand the idea that by overriding these built-in operators that the Python engine uses to do all its arithmetic, you can provide your own classes with arithmetic capabilities. So what have we done through all this series? We started with the empty class, we added in initializers, we added in string conversion, we added in our own lightness method, and lastly we've added in arithmetic capabilities. So what we've got out of all that is a new type, the color class, just like it was a built-in type, and I can do calculations with images, for example, using my new class. And it defines the attributes or the behavior of objects of that type. So there's a term that comes in here, the term encapsulation. It's a fancy way to say it wraps up or puts a little box around a type and limits the operations we can do with it. We can do everything that we define and nothing else, except by writing separate functions, not in the class. But we now have the ability to create and manipulate colors easily. And when you're programming in any new domain, you typically have to think about what are the objects I'm dealing with, how do they behave, and this is going to lead us into the next topic, the next video, which is, given that we've now got all these new capabilities in Python, how do we use them? How does this change the way in which we write programs? So thanks for watching it. That's all for this video.